Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So we are going to talk about the last topic on additional topics in integration, that is on improper integral. Okay, so what does improper integral means? Let's start. So this is the definition of improper integral. So we have learned how to solve integral with some certain function f. Okay, this one. Okay, next we will learn another kind of integral. That is this one. Why is this called improper? Because the boundary is getting larger and larger. Okay, infinite. If you have minus infinity or infinity in your integral, that is what we usually call type 1 improper integral. Improper integral type 1. What about this one? So the boundary is just a real number. Okay, it's just a real number. But the integrand function to be integrated, this is 1 over square root of x. This is becomes unbounded when x goes to 0. This is what we usually call type 2 improper integral. Why? Because the integrand will become larger and larger or smaller and smaller when it goes to some value at between 0 and 1. Okay, but we just want to learn about type 1 problem. For type 2, it will be discussed on another course, but not this course. Okay, let's look at this one. Okay, so integral 0 to infinity of x to the power of e to the x dx. This is just integral 0 to a x. Okay, to a, but then you have a limit process. A limit process. When a goes to infinity, what happened to this integral? Okay, so if you have infinity here, this is limit of integral. What about minus infinity? Yeah, the same. A goes to minus infinity from a to something, x to the power of x to the e to the x times e to the power of x. Okay, careful because we're dealing with limits. The improper integral maybe exists or not. In case the limit doesn't exist, we usually say that the improper integral diverges, or else it is converges to the value. Thus, the problem will be easy. Why? Because we have learned all of this, all of the integral that we have discussed directly, substitution method, and integration by parts technique. You can solve this, and then you have to find the limit when sum of this goes to infinity. Okay, if there's the limit, I means the limit is a real number, it means the integral is converges. But if the limit goes to plus or minus infinity, it is said that the integral uh, diverges. Okay, this is the definition of improper integral. So this one, and this one for both. Okay, you have to be careful, be very careful here. Okay, this is not limit of a to the infinity from minus a to a fx dx. No, yeah, no. So we have to check integral to infinity and integral from minus infinity to 0. Okay, this is an example on improper integral. That is present value or future value of a perpetual. That is a long time income flow. Okay, we will discuss about income flow. So a donor wish to endow a scholarship with gift that provides a continuous income stream. So the income stream is a continuous one with the rate is 25,000 plus $1,200 per year in perpetuity. It means that in a long time. Okay, assuming the prevailing interest rate stays at 5% compounded continuously. Okay, compounded continuously. Don't forget the principal times e to the power of r times t. Okay, what designation is required to finance the endowment? So you are asking the present value of this income stream. Okay, so the donor should equal the present value of an income stream in perpetuity. So we have to calculate this. Okay, we'll calculate the integral first, and let u is this, and dv is e to the power of minus 0.005t dt. Okay, and I have du is just 1200 dt, and we can try to find the integral to find v is minus 20 e to the power of minus 0.05 dt. Okay, and I can change this into this one. How do I get this? This is just using the integration by parts. U times dv. U times dv. So u times v, you can check the v is minus 20 e to the power of minus 0.005t. Okay, so I have this one, uv minus integral of v du. Integral of v du, this is this, to 20, 1000 of this times this. Okay, and I can simplify this. Okay, this is from 0 to t. And this, okay, this is a useful property. If I have something over p divided by e to the k times p t, so the limit is 0. It means when t goes to infinity, e to the power of kt goes to 0 faster than t to the power of p. Okay, so you have this, and the limit of this is just this one. Okay, so the endowment should be $980,000. Okay, so this is the application on the improper integral. Okay, next we will learn about a new chapter that is on sets and counting. Okay, thank you.